Good evening, and welcome to Cozy Sleep Time. Get comfortable and take a slow breath. Let your body relax more and more. Tonight's story is about the breath. Simply listen or let your mind drift. There is no need to focus. Let the quiet story begin. Every moment of every day, without any conscious effort on our part, a quiet and vital process unfolds within us. We breathe. From the moment we are born to the moment we die, this rhythmic exchange of air sustains us, a constant companion that continues even in deepest sleep. The respiratory system is the collection of organs and tissues that makes this possible. It is a system designed with remarkable efficiency, bringing oxygen into the body and removing carbon dioxide, a waste product of metabolism. Understanding how this system works is a first step toward appreciating the quiet miracle of every breath. The journey of a breath begins at the nose and mouth. Air enters through these openings, passing through the nasal cavity or the oral cavity. The nose is more than just an entry point. It is a sophisticated air processor. Hairs inside the nostrils filter out large particles like dust and pollen. The nasal passages are lined with a moist, sticky mucous membrane that traps smaller particles and pathogens. The air is warmed and humidified as it passes through these winding passages, preparing it for the delicate tissues of the lungs. This is why breathing through the nose is healthier than breathing through the mouth. The nose conditions the air, protecting the lungs from cold, dry, or contaminated air. From the nasal cavity, the air travels down the pharynx, a shared passage for both air and food. From there, it moves into the larynx, or voice box, and then into the trachea, the windpipe. The trachea is a sturdy tube held open by rings of cartilage. It runs down the front of the neck and into the chest. At its lower end, the trachea divides into two branches, the right and left bronchi, each leading to one lung. The bronchi are lined with tiny hair-like structures called cilia. These cilia beat in a coordinated wave-like motion, sweeping mucus upward toward the throat, where it can be swallowed or coughed out. This is the mucociliary escalator, a cleaning system that keeps the lungs clear of debris. Inside the lungs, the bronchi branch again and again, like an upside-down tree. They become smaller and smaller, forming a network of tubes called bronchioles. At the very end of the smallest bronchioles are tiny grape-like clusters of air sacs called alveoli. It is here that the real work of breathing takes place. The alveoli are incredibly numerous. There are about 300 million of them in each lung. Their walls are extremely thin, just one cell thick, and they are surrounded by a dense network of tiny blood vessels called capillaries. The total surface area of all the alveoli in the lungs is about the size of a tennis court. This vast surface area is essential for efficient gas exchange. Oxygen from the air in the alveoli passes through the thin walls and into the blood in the capillaries. At the same time, carbon dioxide, a waste product carried in the blood from the body's cells, passes from the blood into the alveoli to be breathed out. This exchange happens by diffusion, a passive process in which molecules move from an area of higher concentration to an area of lower concentration. The concentration of oxygen is higher in the alveoli than in the blood, so oxygen moves into the blood. The concentration of carbon dioxide is higher in the blood than in the alveoli, so carbon dioxide moves into the air sacs. No energy is required. It is a simple, elegant, and continuous process, happening billions of times each day. From the lungs, the oxygen-rich blood travels to the heart, which pumps it out to every cell in the body. The carbon dioxide-rich blood returns from the body to the heart and is pumped back to the lungs to be exhaled. This cycle repeats with every breath. each inhale bringing fresh oxygen, each exhale releasing waste. It is a process so automatic, so continuous, that we rarely give it a thought. Yet it is the very essence of life, a quiet, rhythmic exchange that connects us to the air around us with every single breath. At the center of every breath, working silently and tirelessly, is a single, dome-shaped muscle. This is the diaphragm. It sits at the base of the chest cavity, separating the lungs and heart above from the stomach and liver below. The diaphragm is the primary muscle of breathing, and its gentle, rhythmic movements are the engine that drives the flow of air in and out of the body. Understanding the diaphragm is to understand the very mechanics of breath. The diaphragm is a thin, sheet-like muscle that arches upward like a dome. When it is relaxed, it sits high in the chest, pushing up against the base of the lungs. When it contracts, it flattens and moves downward. This downward movement increases the volume of the chest cavity. According to the principles of physics, when the volume of a closed space increases, the pressure inside it decreases. This creates a vacuum or negative pressure inside the chest. The air outside the body, which is at higher atmospheric pressure, rushes in through the nose and mouth to fill the lungs. This is inhalation. It is not an active pulling in of air, but a passive response to the change in pressure created by the diaphragm. When the diaphragm relaxes, it returns to its dome shape, moving upward. This decreases the volume of the chest cavity, increasing the pressure inside. The air is pushed out of the lungs. This is exhalation. In normal, quiet breathing, exhalation is entirely passive. It requires no muscle effort, only the elastic recoil of the lungs and the relaxation of the diaphragm. This is why breathing is so effortless. The diaphragm does the work of inhalation, and then it simply lets go, and the air flows out on its own. The diaphragm does not work alone. Between the ribs are the intercostal muscles. These muscles help to lift and lower the rib cage, further changing the volume of the chest cavity. When we breathe deeply or rapidly, such as during exercise, the intercostal muscles and other accessory muscles in the neck and shoulders become more active. They help to lift the rib cage higher, allowing for a deeper inhalation. When we exhale forcefully, the abdominal muscles contract, pushing the abdominal organs up against the diaphragm and helping to expel air more quickly. The lungs themselves are not muscular. They cannot expand or contract on their own. They are elastic, spongy organs that passively follow the movements of the diaphragm and rib cage. The surface of the lungs is covered by a thin membrane called the pleura. A similar membrane lines the inside of the chest cavity. Between these two membranes is a thin layer of fluid. This pleural fluid creates surface tension, which holds the lungs against the chest wall. As the chest wall expands, the lungs are pulled along, stretching open like a balloon being inflated. Taking a deep diaphragmatic breath can be a calming practice. When we breathe deeply, we engage the diaphragm fully. The belly expands as the diaphragm pushes downward into the abdominal cavity. This is sometimes called belly breathing. It is the way babies naturally breathe. It is also the way we breathe when we are relaxed and at ease. Shallow, chest-based breathing, which often accompanies stress and anxiety, engages the diaphragm only partially. By consciously shifting to slow, deep, diaphragmatic breathing, we can signal to our nervous system that it is safe to relax. The diaphragm, this quiet muscle at the center of our being, becomes a bridge between the body and the mind, a gentle reminder that we can always return to a state of calm simply by breathing deeply. Once oxygen enters the bloodstream in the alveoli of the lungs, its journey is far from over. It must travel to every cell in the body, from the muscles in the legs to the neurons in the brain. This journey is made possible by the circulatory system, a vast network of blood vessels that reaches every corner of the body. Oxygen transport is a marvel of biological engineering, a carefully coordinated process that ensures every cell receives the fuel it needs to function. The oxygen that diffuses into the blood from the alveoli does not simply dissolve in the liquid part of the blood. If it did, the blood could carry only a tiny amount. Instead, most of the oxygen is carried by specialized protein molecules called hemoglobin. Hemoglobin is found inside red blood cells, which are the most numerous type of blood cell in the body. Each red blood cell contains about 270 million hemoglobin molecules, and each hemoglobin molecule can bind to 4 oxygen molecules. This remarkable design allows the blood to carry about 70 times more oxygen than it could if the oxygen were simply dissolved in the plasma. Hemoglobin gives blood its red color. When it is bound to oxygen, it is bright red. This is why oxygenated blood, the blood that flows from the lungs to the heart and then out to the body, is a vibrant scarlet red. When hemoglobin releases its oxygen, it becomes darker, giving deoxygenated blood a deep burgundy color. This is the blood that returns from the body to the heart and lungs, carrying carbon dioxide for removal. The journey of oxygenated blood begins in the lungs. From the capillaries surrounding the alveoli, the blood flows into small veins, which merge into larger veins, eventually forming the 4 pulmonary veins. These veins carry the oxygen-rich blood to the left atrium of the heart. From the left atrium, the blood passes into the left ventricle, the heart's most powerful pumping chamber. The left ventricle contracts with great force, sending the blood surging into the aorta, the largest artery in the body. From the aorta, the blood flows into a branching network of arteries, which carry it to all parts of the body. The arteries divide into smaller arteries called arterioles, which in turn divide into the tiny capillaries. Capillaries are so narrow that red blood cells must pass through them in single file. The walls of capillaries are extremely thin, just 1 cell thick. This allows oxygen to diffuse out of the blood and into the surrounding tissues. The cells of the body take up the oxygen and use it in a process called cellular respiration to produce energy. The waste product of this process is carbon dioxide. The carbon dioxide diffuses from the cells into the capillaries. It is carried back to the lungs in 2 main ways. Most of it is carried in the plasma as bicarbonate ions. A smaller amount binds to hemoglobin, and a tiny amount dissolves directly in the plasma. The deoxygenated blood, now rich in carbon dioxide, flows from the capillaries into small veins called venules, which merge into larger veins. These veins carry the blood back to the right atrium of the heart. From the right atrium, it passes into the right ventricle, which pumps it through the pulmonary arteries back to the lungs. In the lungs, the carbon dioxide diffuses into the alveoli and is breathed out. This entire cycle takes about 60 seconds. In 1 minute, every drop of blood in the body passes through the lungs, picks up oxygen, travels to the tissues, releases oxygen, picks up carbon dioxide, and returns to the lungs. It is a continuous, ceaseless circulation, a river of life that flows from the heart to the cells and back again, carrying the breath with it to every corner of the body. There is a rhythm to breathing, a gentle repeating pattern that accompanies us through every moment of life. This rhythm is not fixed. It changes with our activity, our emotions, and our state of mind. When we run, our breathing quickens. When we sleep, it slows and deepens. When we are anxious, it becomes shallow and rapid. When we are calm, it is slow and even. The rhythm of breathing is a mirror of our inner state, a reflection of how our body and mind are responding to the world around us. In a healthy adult at rest, the normal breathing rate is about 12 to 16 breaths per minute. Each breath consists of an inhale, a brief pause, an exhale, and another brief pause. The inhale is slightly shorter than the exhale. This ratio, about 1 to 1.5 or 1 to 2, is typical of relaxed breathing. The pause at the end of the exhale is a moment of rest, a quiet suspension between breaths. In some traditions, this pause is considered the most peaceful part of the breath, a moment of complete stillness. The pace of breathing is controlled by a group of neurons in the brainstem called the respiratory center. This center generates the basic rhythm of breathing automatically, without any conscious input from us. It is located in the medulla oblongata, the most ancient part of the brain, which also controls heart rate and blood pressure. The respiratory center sends signals to the diaphragm and intercostal muscles, telling them to contract and relax in a rhythmic pattern. This automatic control is why we continue to breathe even when we are unconscious. But the respiratory center is not rigid. It responds to signals from the body. The most important of these signals comes from chemoreceptors, sensors that detect the levels of carbon dioxide, oxygen, and acidity in the blood. When carbon dioxide levels rise, such as during exercise, the chemoreceptors send a signal to the respiratory center, which increases the rate and depth of breathing. This clears the excess carbon dioxide and brings in more oxygen. When carbon dioxide levels fall, breathing slows down. The body is remarkably sensitive to carbon dioxide. Even a small increase can trigger a noticeable change in breathing. Breathing rate and depth are also influenced by higher brain centers. Emotions, thoughts, and conscious intention can all modify the rhythm of breathing. When we are frightened, the amygdala, the brain's fear center, sends signals that can instantly speed up our breathing. When we focus on a slow, deep breath, the prefrontal cortex, the thinking part of the brain, overrides the automatic rhythm and takes conscious control. This ability to consciously influence our breathing is a unique and powerful tool. The natural rhythm of breathing can be a source of calm and focus. When we simply observe our breath, without trying to change it, we become aware of its gentle rhythm. We notice the cool air entering the nostrils, the pause at the top of the inhale, the warm air leaving the body, the quiet pause at the bottom. By paying attention to this rhythm, we anchor ourselves in the present moment. The mind, which so often races into the future or dwells on the past, finds a resting place in the simple, repeating cycle of the breath. The rhythm of breathing becomes a steady, calming presence, a gentle wave that rises and falls within us, always there, always constant. Breathing occupies a unique and fascinating position in the human body. It is both automatic and voluntary. We do not need to think about breathing, yet we can consciously change how we breathe at any moment. This dual control places breathing at the intersection of two major branches of the nervous system. On one side is the autonomic nervous system, which governs the involuntary functions of the body, such as heart rate, digestion, and the automatic rhythm of breathing. On the other side is the somatic nervous system, which controls voluntary movements, such as walking, speaking, and consciously taking a deep breath. The autonomic nervous system itself has two main branches. The sympathetic nervous system is often called the fight or flight system. It prepares the body for action, increasing heart rate, dilating the pupils, and speeding up breathing. It is activated during times of stress, excitement, or danger. The parasympathetic nervous system is the rest and digest system. It promotes relaxation, slowing the heart rate, stimulating digestion, and calming the breath. These two systems work in balance, like a seesaw, to maintain the body's internal equilibrium. Breathing has a direct and powerful influence on this balance. The rate and depth of our breathing sends signals to the brain that can shift the autonomic nervous system toward either the sympathetic or the parasympathetic side. When we breathe rapidly and shallowly, as we do when we are stressed, the brain interprets this as a sign that we need to be alert. It reinforces the stress response, keeping the sympathetic nervous system active. The heart beats faster, muscles tense, and the mind becomes vigilant. This can create a feedback loop. Stress leads to rapid breathing, and rapid breathing reinforces stress. When we breathe slowly and deeply, the opposite happens. Slow, deep breathing activates the vagus nerve, the main nerve of the parasympathetic nervous system. The vagus nerve runs from the brainstem down through the neck and chest to the abdomen, connecting to the heart, lungs, and digestive organs. When it is activated, it sends signals that slow the heart rate, lower blood pressure, and promote a state of calm and relaxation. The feedback loop works in reverse. Calm leads to slow breathing, and slow breathing reinforces calm. The effect of slow breathing on the heart is particularly interesting. With each inhale, the heart rate increases slightly. With each exhale, the heart rate decreases slightly. This is called respiratory sinus arrhythmia, and it is a normal and healthy phenomenon. When we breathe slowly and deeply, the difference between the heart rate on the inhale and the heart rate on the exhale becomes more pronounced. This variation is a sign of a healthy, responsive nervous system. Slow breathing also helps to synchronize the heart rate with the breath, creating a harmonious rhythm throughout the body. The relationship between breathing and the nervous system is a two-way street. Not only does our emotional state affect our breathing, but our breathing can also affect our emotional state. This is why conscious breathing practices are so effective for managing stress and anxiety. By simply slowing down the breath, we can send a powerful signal to the brain that it is safe to relax. We can shift the nervous system from a state of alertness to a state of rest. This is not a trick or a placebo. It is a direct physiological pathway. The breath is a bridge between the conscious mind and the automatic body, a tool that is always available, always with us, ready to help us find a moment of peace. In a world that often feels fast and demanding, the simple act of breathing slowly and deeply offers a refuge. It is a practice that requires no special equipment, no training, and no particular setting. It can be done anywhere, at any time, and its effects on the body and mind are profound. The peace of slow, deep breathing is not just a feeling, it is a physiological state, a shift in the nervous system that brings the body into a condition of rest, repair, and renewal. When we take a slow, deep breath, we engage the diaphragm fully. The belly expands as the diaphragm pushes downward, creating space for the lungs to fill completely. This deep inhalation stretches the lungs and stimulates stretch receptors, which send signals to the brain to calm the nervous system. The exhale, which is even more important for relaxation, is long and gentle. As we exhale, the heart rate slows, the muscles relax, and the mind becomes quiet. The exhale is the body's natural relaxation response. One simple and effective technique is known as the physiological sigh. It is a natural breathing pattern that the body uses spontaneously to relieve stress. It consists of a double inhale through the nose, a quick sip of air followed by a deeper inhale, followed by a long, slow exhale through the mouth. This pattern helps to reinflate tiny air sacs in the lungs that may have collapsed during shallow breathing. It is remarkably effective at reducing tension and restoring a sense of calm. Another common practice is to extend the exhale. Breathing in for a count of 4 and out for a count of 6 or 8 can have a powerful calming effect. The longer exhale activates the parasympathetic nervous system more strongly, signaling to the body that it is safe to rest. This type of breathing can be practiced for just a few minutes to quiet a racing mind, to fall asleep more easily, or to find a moment of stillness in a busy day. Slow, deep breathing also improves the efficiency of gas exchange. When we breathe shallowly, only the lower parts of the lungs are well ventilated. The upper parts receive less air, and gas exchange is less efficient. Deep breathing fills the lungs more completely, bringing oxygen to all parts of the lungs and improving the exchange of oxygen and carbon dioxide. This can lead to a feeling of increased energy and mental clarity as the body receives a fuller supply of oxygen. The practice of slow breathing has been used for thousands of years in many different traditions. It is a central element of meditation, yoga, and mindfulness practices. But its benefits are not tied to any particular belief system. They are grounded in the basic physiology of the human body. Anyone can benefit from taking a few moments to breathe slowly and deeply. As we bring our attention to the breath, we may notice that it becomes naturally slower and deeper. We do not need to force it. We simply need to pay attention. The breath is always there, waiting for us to notice it. It is a constant companion, a rhythm that we carry with us through every moment of life. In the peace of a slow, deep breath, we find a stillness that is always present beneath the surface of our busy minds. We find a way to return to ourselves, to the simple and profound experience of being alive, one breath at a time. As our story ends, let the quiet ideas settle softly. Your body can continue to relax, breathing slow and steady. If sleep is near, let it arrive naturally. Thank you for spending this moment here on Cozy Sleep Time. Return anytime for another peaceful journey. Good night.